Electrical resistivity surveys offer the ability to inexpensively collect vast quantities of three-dimensional subsurface data. Environmental sciences, mining, archaeology, and many other disciplines can benefit from these measurement techniques. However, their large irregular data sets offer significant challenges related to analysis and visualization. CTEC's EVS and MVS excel in their ability to address these complex issues. Airborne geophysical reconnaissance was used to identify potential flow paths for mercury-rich acid water entering Clear Lake at the Sulphur Bank Mercury Mine. Magnetic and electromagnetic conductivity surveys were conducted over a 12-square-kilometer area that included the Oaks Arm of Clear Lake and the Sulphur Bank Mercury Mine. These surveys identified 4 magnetic and/or conductive anomalies that may represent groundwater conduits towards or away from the Herman impoundment. An anomaly that extended from Herman impoundment through a waste rock dam and into Clear Lake was selected for a more detailed ground electromagnetic conductivity survey. The combined results of the airborne and ground surveys provided a detailed lateral depiction of conductive zones, which are the most probable pathways for groundwater flow. These surveys also identified near-surface areas that may contain elevated concentrations of sulfide minerals that weather to produce acid groundwater. The Sulphur Bank Mercury Mine was an excellent site to evaluate geophysical techniques because an extensive network of groundwater monitoring wells had already been established there as part of a remedial investigation and feasibility study. Fugro Airborne Services flew the airborne geophysical reconnaissance of the Oaks Arm of Clear Lake, including the SBMM, on August 9th through the 17th, 2000. The spacing between each flight line was roughly 50 meters, with samples every 3 meters along each line and every 1 meter in depth. This resulted in nearly 1.5 million irregularly spaced samples. CTEC software processed this massive data set to provide a volumetric mapping of the resistivity data that was conformal to the topography and geology. The preliminary dataset for the Sulphur Bank Mercury Mine Superfund site was provided courtesy of the Geosciences Division of the Water and Energy Team at the U.S. Department of Energy's National Energy Technology Laboratory. The effort was funded by U.S. EPA Mine Waste Technology Program. A 3D resistivity and IP survey was conducted at Copper Hill, the oldest copper mine in New South Wales, Australia. Copper porphyry with minor gold and palladium mineralization were found to occur in structurally controlled fractures and quartz veins. However, due to the very complex geology, large differences in ore grades were found in drill holes that were less than 200 meters apart. To map the ore deposit more accurately, a new 3D resistivity and IP survey using pole-dipole arrays was used. Drill hole surveys in the shallow western region confirm a high correlation between zones having more than 0.72% copper and chargeability greater than 35 millivolts per volt. The data was provided courtesy of Arctan Services Proprietary, Golden Cross Resources Australia, and Geotomo Software. A three-dimensional electrical imaging survey was carried out at Lernacken in southern Sweden over a closed sludge deposit using a pole-pole array, a roll-along technique for 3D resistivity data acquisition with multi-electrode arrays. The former sludge ponds containing highly contaminated groundwater clearly show up as low resistivity zones in the top 2 layers. This was confirmed by chemical analysis of samples. The low resistivity areas in the bottom 2 layers are due to saline water from a nearby sea. The data was provided courtesy of Giacomo Software, Penang, Malaysia.